I said I would get you a more interesting mass composition to empirical formula problem, one that doesn't just have a straight up 2-to-1 ratio. And so here it is. I have a bag of stuff, or let's call this a bottle of stuff. Maybe it's in a liquid form, and it happens to be 2.04% hydrogen, 65.3% oxygen, and 32.65% sulfur. What is the empirical formula? What's our best stab at the empirical formula of this substance? So what we do, like we do in all of these problems, let's just assume we've got 100 grams of the stuff. So if we have 100 grams of the stuff, so if we assume 100 grams, so if let me do that in a good yellow. So let's say assume I have 100 grams. So if 100 grams, how many grams of hydrogen do I? If I have 100 grams total, 2.04% of that is hydrogen. So I have 2.04 grams of hydrogen. I have 65.3 grams of oxygen. And I have 32.65 grams of sulfur. Now what we need to do now is figure out how many moles of hydrogen is this, how many moles of oxygen, and how many moles of sulfur. Then we can compare the ratios, and we should be able to know the empirical formula. So how much does 1 mole of hydrogen, what is the mass of 1 mole of hydrogen? Let me write that. So 1 mole of hydrogen. Well, we know what the mass number for hydrogen is. It's 1. The atomic, and especially even the atomic, let's say the atomic weight also for hydrogen, if we were to take it on Earth, the composition, you pretty much just find hydrogen nucleuses that, if it's neutral, it has an electron, but it has no neutrons. So it has an atomic mass of 1 atomic mass unit. So 1 mole of hydrogen has an atomic. So if you have a ton of hydrogens together, or a mole of them, not a ton, I shouldn't say, but a ton is actually maybe, well, no, you have a mole of them. You have 6.02 times 10 to the 23 hydrogens. Then you take hydrogen's atomic mass number in atomic mass units. You say, well, it'll be that many grams of hydrogen, right? So if we immediately look up here, if we have 2.04 grams of hydrogen, how many moles of hydrogen do we have? Well, 1 mole is 1 gram, so we have 2.04 moles of hydrogen. Notice, this said what the mass of the hydrogen is. This tells us how many hydrogen molecules we have. Remember, this is 2.04 times 6.02 times 10 to the 23 hydrogen atoms, moles of hydrogen. Or maybe I should write that down. So 1 mole of hydrogen, there you go. And then oxygen, 1 mole of oxygen. Oxygen's mass number, in case you forgot, is 16, right there. Oxygen's mass number is 16. So 1 mole of oxygen has a mass of 16 grams. 6.02 times 10 to the 23 oxygen atoms has a mass of 16 grams. So how many moles do we have here? Let's see. We have more than, let's see, so if we take 65, let me write that. We have 65.3 grams of oxygen. And we have 16 grams per mole, so you divide by 16. It equals 4.08125. I don't want to get too precise here, but let me just write that. 4.08 moles of oxygen. So let me write that in oxygen color. So I have 4.08 moles of oxygen. And then finally, sulfur. What is sulfur's atomic mass? The one thing I will never forget about sulfur is its smell. There's a city in Louisiana, which we used to drive to all the time. I think we had some family friends there, called Port Sulphur. And they did a lot of sulfur processing there. And lucky for the residents, at least at the time, I apologize if they fixed the issue, it smelled like sulfur, which smells like rotten eggs. But anyway, 1 mole of sulfur. 1 mole of sulfur. Where it is right there. So sulfur's atomic mass is 32 atomic mass units per sulfur atom. So a whole mole of it is going to have a mass of 32 grams. So mole of sulfur, not a mule. Maybe I should invent a new unit called the mule. So a mole of sulfur is 32 grams. So how many moles do we have? We have a little bit more than 1, but let's be precise here, just because everything else is a little bit of a decimal. So if we have we have 32.65 grams of sulfur, and we divide by the number of grams per mole, divided by 32 grams per mole. We have 1.02 moles of sulfur. And this was hydrogen up here. So here you should hopefully see a pretty good ratio here. For every one sulfur atom, I mean, the ratio worked exactly out. And that's because I did this problem before. I actually made up this problem before we worked. So I made it so the numbers worked out. But 1 mole of sulfur, for every mole of sulfur, so for every 6.02 times 10 to the 23 sulfur atoms, you have 2 moles of hydrogen, right? This ratio is 1 to 2. 2 times 1.02 is 2.04. And then for every 1 mole of sulfur, you have 4 moles of oxygen. Right? If you multiply this times 4, you get 4.08. So the ratio of hydrogen to sulfur to oxygen is, for every 1 sulfur, we have 2 hydrogens, and we have 4 oxygens. So the empirical formula of this is H2, and then we have 1 sulfur, and then we have 4 oxygens. And this is sulfuric acid, one of the things you would least like poured on you most of the time. Anyway, hope you found that useful.